Okay, some of you might have heard already, but you can now use Python inside Excel. In this video, I will show you some basic examples of how to use it, and I will guide you through a real-world example to give you an idea of the possibilities. In that example, I will show some very useful Pandas features and some more advanced charts. Towards the end, I will also share my personal opinion about this new feature and point out some limitations. But before we start, a quick shout out to Luke. Luke was kind enough to connect me with the people from Anaconda so that I could test this feature. So thank you very much, Luke and the team from Anaconda, and with that said, let's dive in. Okay, so let us start with a basic example. Under the formulas ribbon, there's a new Python section. When I click on the Python logo, you will notice that the appearance of the formula bar changes. This is where you can now write your Python code. For the first step, I will create a data frame with the command df=, and then simply select my Excel table here on the left. It doesn't have to be a table, by the way. A normal cell range will also work. To execute the code, I will press Ctrl and Enter. If you just press Enter, it will insert a new line. So now the data source is our table. In my case, the table name is 𝗟𝗜𝗡𝗦𝗧𝗔𝗠𝗣𝗦, and as it is correctly recognized, it has a header row. In the cell where I wrote the Python code, the data frame object now appears. So as you might already know, everything in Python is an object, and we can store that object in a cell. I can also get a preview of what the data frame looks like when I click on the following button, and then you can see the head and the tail of the data frame. Now that we have our data frame, you can use all the different Pandas functions. I named my data frame df, so in the next cell I just need to type df, and for this example I will use the describe method to get some statistical insights into the data. When I execute the cell using Ctrl and Enter, Excel returns the object. In this case, the describe method returns a data frame. And if you actually want to print the data frame to Excel, you can select Excel value from the drop-down list. You will then see your data directly in Excel. Likewise, I will calculate the correlation. But this time, instead of using my df variable, I will refer to the cell that holds the data frame object, which is h2 in my case. Then on my data frame object, I can call the correlation method. And as before, we get a data frame in return. However, I will adjust the output to insert the data into the spreadsheet. Okay, and now let's proceed with some basic plots. With the integration of Python, we can tap into various plotting libraries. For my demonstration, I will use Matplotlib to craft a scatter plot. When I run the code, it returns an image object. However, as with the earlier examples, I want to display the actual chart. So I just need to switch the output. As a result, we have an image stored in a cell. You can right-click on this image to create a reference to the cell. And now we have an Excel image with our scatter plot. Next, I plan to generate a Seaborn pair plot, which only requires one line of code. The execution of this cell might take a moment, but once complete, it also returns an image object. Similar to before, I will create a reference for this image. And there we have it, our pair plot. This can be useful for visualizing the linear correlation among all dataset variables and displaying the distribution. Okay, and lastly, I will generate a linear regression plot for two distinct variables. Once again, in Seaborn, we only need one line of code for this. Okay, so those were some basic examples that give you some general idea of this new feature. Now let us move on to a real-world example. Here in the datasheet, I have a transaction table of sales for 5 different stores in Japan. We have there the city where the store is located, the information of the customer, so if the customer was a member or not, and the gender of the customer. Next, we have the information about the product line, unit price, quantity, date and time of the purchase, the payment method, the rating from the customer, and the sales amount, which is the unit price multiplied by the quantity. As before, this data is an Excel table, and I named it table sales. Okay, and now I have taken this data and conducted some analysis using Python. First, I loaded the data frame and named it data. After loading the data, there wasn't much cleanup needed. The main thing I did was converting the date and time column into a datetime object, which I needed for my time and date-based analysis. And I have also an important hint here. The cleanup process is in a cell below the actual data frame. And this is important because I refer to the data variable, which should be defined in a cell above my current one, as the Python code is validated from top to bottom and left to right. With that said, let me show you my code that returns the top 5 selling products. I grouped the data frame by product, and following that I specified the aggregation mode. And the next part is pretty cool. Instead of hard coding the aggregation method, I linked it to cell C7. I named that cell 𝗟𝗘𝗦𝗧𝗜𝗢. This is pretty neat, because now you can combine the flexibility of Excel with Python. So before I linked it, I hard-coded the aggregation method sum in my Pandas code. I then inserted a drop-down menu and named the cell 𝗟𝗘𝗦𝗧𝗜𝗢. And now in the Python code, you could just type out the cell reference, or if you delete it again, you could also just select the cell. And when I execute the code, it is calculated correctly. Now the cool part is that I just need to change this cell here, and then all my calculations will show the average sales amount. When I do this, you will also notice that all my charts are also being updated. In fact, if we look at my chart for the top 5 selling products, you will see that I have done the same for the colors for the bars. This is linked to the following cell. Okay, so let me reduce the size of the formula bar, and then from the drop-down menu, I will select another color. Doing so will change the colors of the bars. Okay, and for the next analysis, I will group the sales by weekday. Doing this in Pandas is actually not too complicated. On the data frame, I will create a new column using the assign method. The new column will be named weekday, and I will extract the weekday from the date column. I will then group the data by this new column, aggregate the sales, and rename and reset the index. And another quick note here. I'm using a lot of Pandas steps one after each other. I think it makes the code easier to read. But if you like, you can do each step one at a time. However, if you want to learn more about chaining different Pandas methods, I suggest my following video. In that video, I will walk you through how to chain Pandas methods and also explain why you might want to use that approach. I've put the link to that video in the info card above and in the description below. Okay, so now that we have the sales grouped by weekday, we can also plot it. For this, I wrote the code next to the table. And here's also a fun fact. I didn't write all the code myself, I got help from ChatGPT. Okay, next up I calculated the sales per hour. Again, not much Pandas code is needed for this type of calculation. And if we look at the chart, most customers seem to do their shopping after work, especially from 7 PM onwards. So during these peak hours we might need additional staff and cashiers. With that insight, let's move on to the next analysis. Here I utilize the Pandas method %change to calculate the month-over-month growth rate. I then asked ChatGPT to provide me with the code to plot the sales amount by month and on the secondary axis the growth rate. And as a result, I've got back the following chart. Frankly speaking, I think using native Excel charts would have been quicker for this purpose. Also, all the charts I choose here are fairly basic. There is really no need to overcomplicate things by using Python for this. However, I will also demonstrate a scenario where you might actually want to use a Python chart. For the following heat map, I created a pivot table using Pandas to display the sales amount by product line and month. I then plotted this new data frame with a Seaborn heat map. The resulting chart has a color scale. The darker the color, the higher the sales. The y-axis represents the months, while the x-axis displays the different product lines. And from this heat map, we can see that sales for groceries remain relatively consistent throughout the year, which kind of makes sense. However, for the electronics, we will notice higher sales in a specific month, so we might want to dig deeper into these insights. So this is just one example of a more advanced chart that would be difficult to replicate in Excel without Python. Obviously, you shouldn't just pick a chart because it looks fancy. It should simply convey the message of your insights. Okay, and now that you have seen some potential use cases, let me share my thoughts about running Python code in Excel. In general, I think it's fantastic that you can now integrate Python with Excel. It just adds another tool to your toolbox. Especially when dealing with dates and times, certain calculations are much more straightforward in Pandas, at least in my opinion. However, Excel also offers another powerful tool for data cleaning and aggregation, Power Query. If you've ever worked with Power Query before, you know how powerful it is. Also, even though I'm not a beginner with Pandas, I often need to test my code and tinker around with it. And I have noticed that the more Python calculations you have in your spreadsheet, the slower the calculation becomes. So I find it rather clunky to do my exploratory data analysis directly in Excel. Instead, I have been turning to a Jupyter Notebook. Once I tested my code in a Jupyter Notebook, I plugged it into Excel. Now, to quickly get the Excel data into a Jupyter Notebook, I created my own add-in, which is called My Toolbelt. With it, I just click a button, select the cell range I want to analyze, provide a title if I wish, and then hit OK. This action generates a new Jupyter Notebook in my Workbooks directory. When I open it up, I have my title, library imports, and the respective code to load the Excel data as a Pandas data frame with the correct path to the spreadsheet, sheet name, columns, and row count. So with this add-in, I can speed up my analysis, and now I also have a clear separation between my data and the code I write. If you also want to install the add-in, I will drop a link in the description below. However, it is worth noting that the Jupyter Notebook feature is only available in the paid version. Okay, and now let's get back to the native Python functionality in Excel. In this video I showcase examples using Pandas, Matplotlib and Seaborn. However, you can also access additional packages available in the Anaconda distribution like StatsModel, SciPy and scikit-learn. By default, many of these packages are directly loaded when initializing the environment. And that is why, in my example, I didn't need to input the library separately. So in my upcoming videos, I also want to explore the possibilities of using basic machine learning with scikit-learn directly in Excel, because those type of calculations cannot be done with Power Query. And speaking of Power Query, you can actually also connect Python to your Power Query tables, which is something I haven't shown in this video. Lastly, before you go, let me highlight some limitations. As of now, animated Python charts, like those from Plotly, aren't supported. Also, the Python functionality is currently exclusive to Excel Desktop 365 beta channel users, and it only works on Windows at the moment. Another constraint is that you cannot connect to external files using Python. So if you want to connect to other files and folders, you would need to use Power Query for this. Moreover, only the libraries supported by Anaconda are available for use. So if there's a third-party package that isn't part of the Anaconda distribution, you won't be able to use it. And with that said, I would love to hear your thoughts on this new functionality. Share them in the comments below. And as always, thanks for watching and I will see you in the next video.